You know that scene? It's the Winter Olympics. You flip on the TV, and there are people sliding this huge granite rock down the ice.
Hmm.
And two other people are just screaming at it, scrubbing the ice like their lives depend on it.
Yeah, it looks like aggressive housekeeping.
Exactly. But looking at the research we've pulled for today's deep dive, this is actually some seriously high-level physics.
Oh, it really is. We're talking about thermodynamics,
Yeah.
tribology, which is, just the science of friction.
Right. So our mission today is to get into that invisible science.
Mhm.
We want to figure out how all that frantic sweeping turns a game of like sheer force into one of incredible precision.
Let's do it.
So the fundamental question, why are they sweeping?
Okay, so there are three reasons. The first one is the obvious one, cleaning. A tiny piece of debris, a hair, it can totally ruin a shot.
Okay, that makes sense.
But the real magic, it happens at the microscopic level. You're interacting with something called the pebbles.
Right. Those are the little water droplets they spray on the ice to give it that bumpy texture.
Exactly. If the ice was perfectly flat, a vacuum effect would just stick the rock to it.
It wouldn't go anywhere.
Not at all.
Yeah.
So the pebbles reduce that surface area. But when the sweepers are going at it, they're not just polishing them, they are heating them.
And that's the part that really got me in the notes. They are creating enough frictional heat to actually change the state of matter.
It's instantaneous. They're creating what's called a meltwater film.
A meltwater film. So
Yeah.
like a tiny layer of water.
So tiny. We're talking nanometers to micrometers thick. It's incredibly fleeting.
So it's not like they're creating a puddle. It's a momentary lubricant.
That is the perfect word for it. And that lubricant, it lowers the coefficient of kinetic friction.
Okay, and in plain English, that does two things.
Right. One, it lets the stone travel farther, maybe a few extra meters. But the big one is that it helps it hold the line.
It delays the curl.
It delays the curl.
Which is all about efficiency. You're spending all this human energy to reduce friction and, optimize a path. And speaking of optimizing things, I think this is a good time to mention our sponsor, Embersilk.
Absolutely. If you're looking to optimize your business, or even just your personal workflows, Embersilk is really the partner you want.
They're experts in AI training, automation, and software development.
It's all about finding those little friction points in your systems and figuring out where agents can make the biggest impact. You should check them out.
You can find everything at embersilk.com.
So, okay, we know sweeping creates that meltwater film, which makes the rock go straighter for longer.
Right.
But that leaves the biggest question. Why does the rock curl at all?
And not just that, why does it curl the wrong way?
The wrong way? What do you mean?
Well, think about it. If you slide a glass on a table and spin it clockwise, friction makes it curl left, right, opposite the spin.
Yeah, that's standard physics.
But a curling stone, you spin it clockwise, it curls right, it goes with the spin.
That little puzzle stumped physicists for decades. But now we have the scratch guiding theory.
From Nyberg and his team, yeah.
It all comes down to the shape of the rock.
The running band.
You got it. The bottom of the stone is actually concave, so it's only that narrow ring that touches the ice.
And that ring is rough.
It's rough. So as the stone rotates, the very front of that running band is scratching microscopic grooves into the tops of those ice pebbles.
Oh, wow. So it's like a record needle carving its own track as it goes.
It's a perfect analogy. The front scratches the groove, and then a split second later, the back of the running band falls right into that fresh track.
So it's not being pushed by friction, it's being guided.
It's guiding itself on a path it just created.
That gives the players so much leverage. I mean, if you can influence how those tracks are made, you can basically steer the stone, that's what Broomgate was all about, wasn't it?
The 2015 controversy, it was wild. Players started using these broom heads with, abrasive directional fabric.
They weren't just melting the ice anymore, they were sandpapering it.
They were. They could carve such deep tracks that they could literally joystick a bad throwback on course.
It just completely broke the game. It wasn't about the skill of the thrower anymore.
Not at all. The World Curling Federation had to step in, and now the regulations for 2026 are super strict. Sweeping is about managing friction, not, re-engineering the ice mid-shot.
It really changes how you watch it. You realize sweeping is like real-time micro-machining of a surface.
It is. It brings up a more philosophical idea for me.
Oh, go on.
We're watching humans use targeted energy to manipulate a solid reality ice and turn it to liquid just long enough to change the path of this heavy 20-kilogram rock.
That's a really cool way to think about it.
It just makes you wonder,
No.
if we can do that,
Yeah.
what other solid realities in our own lives are actually more malleable than we think?
If we just apply enough targeted pressure and heat to the path in front of us.
Exactly. Maybe we just need to start scrubbing.
I love that. Maybe some obstacles just need a little more heat. If you enjoyed this deep dive, please make sure you hit subscribe.
And hey, leave us a 5-star review if you can. It really does help get the word out.
Thanks for tuning in. We'll catch you on the next one.